Hello everyone, myself Piyush and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Wind and Solar Energy, which is offered in second year, fourth semester. And today we are going to discuss the chapter number 4, that is Solar Photovoltaics. Now we are going to talk about the basic of solar cell. So solar energy is ultimate source of energy that we all know and which is naturally replenished in short period of time. For this reason it is called as renewable energy or sustainable energy, right? To make the advantage of solar energy, the variety of technology is used to convert this solar energy to heat and electricity. So we are directly converting our solar energy to the heat energy or to direct electricity. The use of solar energy is involved in energy conversion law. So we need to convert our energy from one form to another form, and because it is the way to use energy source that comes from nature and use it more wisely and effectively. Moving forward, what is solar cell? Now we are going to talk about only solar cell. So we are going to convert our solar energy into directly electricity, right? So solar cell or photovoltaic cell, solar cell are also called as a photovoltaic cell, or we are generally going to use the term that is PV cell. So the PV cell is a device that is made up of semiconductor material. So which type of material is used in PV cell? We are going to use the semiconductor material such as silicon, gallium arsenide and cadmium telluride, etc., that converts sunlight directly into the electricity. Now, when the solar cell absorbs the sunlight, free electrons and holes are created at positive and negative junction. We can also call it as a PN junctions. And if the positive and negative junctions of solar cell are connected to the DC electrical equipment, the current is delivered to operate the electrical equipment. So whenever we are directly connecting our DC electrical equipment to the solar cell, the positive and negative junction diode, or we can say positive and negative junction, will send the electron and operate that DC equipment. Now we have different type of solar cells. So we are going to see the solar cell types. So there are three major cells type that classified by the manufacturing technology and the semiconductor. So first one, that is the crystalline silicon PV module. So two type of crystalline silicon module, that is we can also call it as CSI, C for the crystalline and Si for the silicon, are used to produce the PV module, that is single crystalline silicon, that is single crystalline silicon, or known as a monocrystalline silicon, and multicrystalline silicon. So this is the second one, that is multicrystalline silicon. So which two different type of crystalline silicon module we have? That is the single crystalline silicon module, and second one, that is the crystalline silicon module, and also called as a polycrystal silicon module. Okay, so single crystalline module is also known as a mono, and multicrystalline silicon module is also known as a polycrystalline silicon module. And the polycrystalline silicon module, that is the PV module, has lower conversion efficiency than the single crystalline silicon module. Okay, but both of them have the higher conversion efficiency, that average about 12 to 10 to 12 percentage. Okay, second one, that is the amorphous silicon PV module. So amorphous silicon, or we can say ASI PV module, or thin film silicon PV module, absorb the light more effectively than the crystalline silicon PV module. So it can be made thinner. So we can make this type of ASI PV module thinner than the crystalline silicon module, and it is suited for any application that have high efficiency is not required and low cost is important. So whenever low cost is important, at that time we can use the amorphous silicon module, and high efficiency is not that much of consideration because the typical efficiency of amorphous silicon PV module is around only 6%. That's why over here we are talking that the low cost is important and the efficiency is not important. At that time we can use this type of PV module. Now next one, that is the hybrid silicon PV module, that is a combination of single crystalline silicon surrounded by thin layer of amorphous silicon, provides excellent sensitivity to longer light levels or indirect lights. Now the hybrid silicon PV module has the highest level of conversion efficiency, that is about of 17%. So over here we can see that this is the single crystalline silicon PV module, the second one that is the polycrystalline silicon module, and the last one that is the amorphous silicon PV module. We have not mentioned over here the hybrid one. Okay, now the next, that is the solar cell structure. So the most important material currently used for solar cell production is silicon, which has some advantage as it can be easily found in nature. That is the first advantage of silicon, and does not pollute, does not harm to the environment, and it can be easily melted, handled, and formed into monocrystalline silicon forms, etc. So these are the different advantage of our silicon modules. So that's why we are using as a semiconductor material silicon. Now the commonly solar cell is configured as a large area PN junction made of from the silicons, and here is how the solar cell is going to be work. So over here we have our sun. So whenever sunlight is directly applied to the PV cell, in the PV cell we have P junction and N junction, that is number of electrons and number of holes are separated while the sunlight is directly appeared on the solar cell. So over here as we can see, whenever photons are directly applied to the PV cells, at that time the electron is going to be flow from this direction and holes is going to flow from this direction. That's why whenever we are connecting the direct DC load to the solar cell, the current is flowing from this direction and it is going to operate that DC applications. So this is the solar panel diagram. Now when sunlight strikes solar cell surface, the cell create large carrier as electrons and holes. The internal field produced by the junction separates some of the positive charge, that is holes, and from the negative charge, that is electrons. Now holes are swept into the positive or P layer and the electron are swept into the negative or N layer. Now when a circuit is made, that is whenever we are going to connect any kind of applications, that is DC applications, free electron have to pass through the load to recombine with the positive holes. So it is trying to be in its natural position, or we can say neutral condition. So that's why the electron is going to be travel from the whatever load we are connecting with the PV cells, and the current can be produced from the cell under the illuminations. Now the individual solar cell are connected together to make a module, that is solar cell module or PV module. So solar cell is a single cell, but whenever we are going to connect that solar cell in series parallel combination, we are going to make a solar module, or we can say as a PV module, to increase the current and the modules are connected in the arrays. That is, different modules are connected in arrays and that are called as a solar array or PV array. So if we are talking about the arrays, then this is our solar panel, and in which number of solar cell are installed over here that are connected in series parallel combination to get the desired voltage and current level. So if we require the large amount of current at that time, we are going to connect our cell in series, and if we are requiring the higher voltage at that time, we are going to connect our solar cell in whenever we are requiring high current, at that time we are connecting our solar cell in parallel, and whenever we are going to require a higher voltage level, at that time we are going to connect our solar cell in this series combination. So this is the single module in which different solar cell are connected, and if we are connected this type of different module with the series parallel combination, at that time we can call this complete solar panel array. So we are going to call this as a array. Okay, and this is single cell, this is panel, and this is array. Now, depending on the current and voltage requirement, solar arrays are connected in varieties of way that we already discussed. That is the first one. If the array are connected in parallel, the output current will be increased. So whenever we are connecting our solar panel in parallel, at that time the current is going to be increased. The current will be increased, and whenever the solar cell are connected in series, the output voltage will be increased. So in series the voltage is increasing, and in parallel the current is increasing. Now, solar PV system, that is, this is the solar PV system, that how normally it is going to be operated. So whenever the direct sunlight is applied on the solar arrays, that is number of different panels, the current, or we can say electron, is going to flow from this direction, and it is going directly into the charge controller, where the controller is going to control that charge, or we can say the electron. So if we need to charge our battery, so controller is directly sending that electron to the battery, and whenever battery is fully charged, it is going to given to the load, or we can say DC load directly. But if we have the AC load like our domestic appliances, at that time we require one inverter, so that current from the charge controllers is directly feeding into the inverter, and from the inverter our AC loads are also going to be operated. So this is how our solar PV system is going to be work. Now, solar cell produce direct current, that is DC current. Therefore, they are only used for DC equipments. If alternating current AC is needed for the AC equipment, or backup energy is needed, solar photovoltaic system require other components in additional to the solar modules that we already seen in the figure. Now, these components are specially designed to integrate into the solar PV systems. That is to say that they are renewable energy product or the energy conversion products, and one or more of the component may be included depending on the type of the application that we are using. And the component of the solar photovoltaic systems are, which are the component that we already discussed, are first one, that is the solar module or PV array, is the essential component of the any solar PV system that converts sunlight into the direct electricity, or we can say DC current. Now, second one, that is the solar charge controller. What is the role of solar charge controller? It's regulate the voltage and current from the solar array, charge the battery, prevent battery from the overcharging, and also perform the controlled over discharge. Okay, this is the function of our solar charge controller. Next one, that is the battery source. Battery, that is store the current electricity that produced from the solar array for using when the sunlight is not available. So whenever sunlight is not available, we can use the battery to apply or give the supply to our load, and night time or other purpose, or we can say in monsoon season also we can use our battery system. And next one, that is the inverter. So inverter is a critical component of any PV system that converts DC power output of the solar array into the AC for the AC appliances, because most of the appliances that are available at our home or domestic applications are work on the AC. Next one, that is the lightning protection. So prevent lightning protection prevents electrical equipment from damaging caused by the lightning or introduction of high voltage surge. It is required for the large size critical solar PV system, and which include effective grounding. So whenever we are installing the solar farms, at that time we require lighting protection. Otherwise, at our domestic appliances or domestic purpose, we are not installing this lightning protection for our homes. Okay, so whenever large solar farms are installed over the region, at that time we require this kind of protection also. And that's it for today's video. Thank you, and if you find any kind of query, then please feel free to ask me. Thank you.